Today, we'll learn about roots, or solutions, in polynomial functions. In a polynomial function, when x minus k is a linear factor, k is the polynomial's 0, which is also a root, or solution, and on the graph, it represents the x-intercept. These expressions are different in name only but have the same meaning. Let's consider a polynomial function y equals x plus 3, x minus 1, x minus 2. X plus 3, x minus 1, x minus 2 are linear factors, and negative 3, 1, 2 are zeros, which are also roots, or solutions. And on the graph, they represent x-intercepts. When the number k is repeated multiple times, the shape of the graph at the x-intercept varies based on the multiplicity n value. If n equals 1, it's close to linear. If n equals 2, it's closer to a parabola. If n equals 3, it's closer to a cubic function. Now, let's examine a graph with a single x-intercept. Here's a linear function y equals x minus 1. The x-intercept is 1. Here's the graph of y equals x minus 1 squared. At x equals 1, it's multiplicity 2, and the graph is parabola. Here's the graph of y equals x minus 1 cubed. At x equals 1, it's multiplicity 3, and the graph is cubic function. Here's the graph of y equals x minus 1 to the power of 4. At x equals 1, it's multiplicity 4, and the graph is quartic function. Here's the graph of y equals x minus 1 to the power of 5. At x equals 1, it's multiplicity 5, and the graph is quintic function. Now let's look at an actual polynomial function. Y equals 8x squared plus 2x cubed minus x to the power of 4, a quartic function is given. Pulling out the common factor negative x squared, and arranging the content inside the parenthesis in descending order, we factorize it. Then, the x-intercepts are negative 2, 0, and 4. You can see the graph passing through these three x-intercepts. In the factorization, the two linear factors, x plus 2 and x minus 4, each have multiplicity 1. So at the x-intercepts negative 2 and 4, the graph is closer to a straight line. It passes through the x-intercept. In the factorization, x squared has multiplicity 2. So at x equals 0, it appears as a parabolic shape. It touches the x-intercept and changes direction. If the graph of a polynomial function has several turning points, the function can have relative maximum and minimum values. A relative maximum is the function value at a turning point where the function goes up and then falls down. And a relative minimum is the function value at a turning point where it falls down and then goes up. Next time, we'll learn how to find the zeros of a polynomial function. See you next time.